everyone. Today, this session is turning text into engaging visual stories using OpenVINO. And today we have with us Anisha. Welcome, Anisha. Thank you for joining us today for this very exciting session. The stage is yours.
Thank you so much, and thank you for the warm welcome. I'll try to share my screen first. Give me a second. Yeah, I hope my screen is visible. If one of you can confirm.
Yes, it's perfect.
All right. So thank you so much for the great introduction, and hello everyone. Good evening, good afternoon, and good morning. No matter from which part of the world you're joining from, and the QR code that you see on the screen, I would like to request you to just quickly scan or click a picture, and request to spend some time at the end of today's session. It's a feedback session which can help me, analyze how I can make my future sessions better and more resourceful for you guys. And thank you so much again. I'm Anisha Udayakumar. I work for Intel as an AI software evangelist, and I'm based in India. If you see, this is my overall evangelist team who are globally spread across. And no matter what, from which part of the world you are from, one of us are there to help you guys. And our core job, is to help developer community, especially like you, to help you leverage toolkits and resources that are open sourced and available, that can boost your AI journey. And to just quickly get started with today's session, I hope most of you would have got a chance to see the first series of this session, which was the introduction to OpenVINO toolkit. And today we are going to see, deep dive into the heart of AI performance optimization. So we all know the true potential of any AI model that we pick today, right? It's everywhere almost, and it's being productionalized and scaled for businesses. But imagine traditional computing where AI as a shift from manual gear to automatic transmission. I'm sure most of you here know how to drive a car. So this transition is smoother, faster, and gets you to your destination, with a lot less effort. And that's exactly what we're going to deep dive today, especially explore more into generative AI. What are all the models out there which can, in seconds, that can convert your text prompts into stunning visuals. And more to it, if you are looking at, developing a solution and you have a problem statement in hand where you are going to leverage these sophisticated Gen AI models, then this session is going to be all the more useful, where you'll be leveraging open source toolkits to optimize your entire deployment journey. Just a quick note, I would like to know how many of you have joined today are code developers, or have worked in building AI solution, or been part of um, AI team in your organization. And that'll help me keep this session more interactive. Thank you once again. So I'm sure most of you would have been part of session which has briefed about what generative AI is. On a quick note, it's the very essence of creativity and innovation in artificial intelligence, right? But what it means for developers is, we have lots of tools not only to solve problems, but we can also explore a world of possibilities, where that we weren't able to reach a few years back. So we are talking about custom data sets which are tailored to your specific needs, and the synthetic data that's available that can improve models without compromising on privacy and other things. Today, if we see, we have it. generative AI is not just a buzzing word, right? It's revolutionizing industries with creative use cases, like in a science fiction movie. I'm sure many of you would be familiar with Unity platform. Um, for example, it's an engine which is traditionally used for game development. But today, if you're a professional interior designer, we can just give text prompts saying, "I need a contemporary green pastel colored kitchen," and it'll be able to give you, stunning interior designs on top of which, as a domain expert, you can work on, which can save tons of time, and tailor your solution and give the best user experience or customer experience in terms of designing and so on. It's just 1% of what we know, but the use cases are many, and this is the shift that we are witnessing today. I'm quickly jumping into the major pain points that we see when we'll have to deploy a generative AI model. Just to give you an example or put it in simple terms, we have a model called Stable Diffusion, or many of you would be using ChatGPT, where you give text prompt and DALI inside ChatGPT can convert it to a stunning visual, or Stable Diffusion kind of model can just uh, you know uh, bring life to the text prompts that you give. um, but when it comes to scaling these models, it's not an easy task. We face these pain points where sometimes it consumes a lot of memory. It's not easy to deploy it on a simple machine, or it takes a lot of time to wait for the results, taking a toll on the customer experience if we are building a real time solution using Gen AI. And we have many smart solutions today to address these. But today we are not just discussing these pain points, we are also going to see how we are going to address each one of them. So we'll pick one generative AI model, say for example, Stable Diffusion, and break down these pain points and see how we can address them and scale it up and build a business solution out of it. I'm sure it's easy as a developer to build a solution out of it, but to productionalize is where the critical part lies. So that's what we are going to deep dive and see today. And as I mentioned, a quick recap on what we saw in our previous session. The solution, one of the solution to the this problem statement that we saw is OpenVINO, and it stands for Open Visual Inference, for visual inference and neural network optimization. It's an open source toolkit which is powered by one API under the hood. It's not just for computer vision models. You can also optimize NLP model, the large language model that are there today, the Gen AI models, and other transformer based models as well. As a developer, if you see, your journey looks like this: you have your model, you have trained it to solve a problem, and you have it ready. Now, when it comes to deployment, just before deploying it, you optimize it using OpenVINO toolkit and you deploy it. So, as a developer, visualize you have one of your model in these frameworks like PyTorch, TensorFlow, and so on. You will be able to optimize it using OpenVINO and deploy it across these hardwares. So as a developer, your nightmare is gone. You will just have to code once and deploy it anywhere on these Intel hardwares and others. And not you don't have to worry about the operating system that you're working on. No matter what you're working on, Windows, Linux, or Mac, you will still be able to leverage OpenVINO to optimize your model and boost the performance. Um, Again, we saw there are a couple of key components as part of OpenVINO toolkit. One such is OpenVINO Model Converter API. Um, if you are a C++ developer or a Python developer, you will be able to leverage this. If you're using one of these frameworks like .pb is TensorFlow, .pt is PyTorch. So if your model is in one of these frameworks, you'll be able to leverage Model Converter, optimize and serialize your model to um, the precision format of floating point 16 or floating point 32, which means you now have the OpenVINO format of the optimized model or intermediate representation or IR files. This IR file consists of .xml and .bin, where the XML file hosts the architecture of your model and .bin file hosts the weights and biases. Not just that, we also saw if we need more performance, then we go for the option of quantization, which you can leverage through neural network compression framework within OpenVINO toolkit. Again, using one of this algorithm, you'll be able to simplify your complicated neural network to the simplest form. What it means is you'll be able to run your model faster by one of the means is reducing the size of the model, improving the performance in other means, and so on. So if you're a Python developer, it's just pip install an NCF. And for OpenVINO, it's pip install OpenVINO, as simple as that. So this will be the favorite line of code for all the Python developers. Today I have a quick demo for you. So let's just or begin with the demo. I'll show you a hands-on. If you are a non-technical person, do not worry. I'll try to break down the terms into simple terms. And yeah, before getting into the demonstration that I wanted to show you, if you're interested in exploring other notebooks as simple as object detection to classification, or if you want to explore OCR and other models, you can leverage or scan this QR code and explore OpenVINO notebooks, which is in our GitHub repository. It's completely open source. Any developer can explore and learn from it. So the steps are very, very simple. You first clone the repository from GitHub, and you create the environment, you install the requirements, and finally you launch the notebook. So when you launch the notebook, this is what you see, and you will have like 100 plus notebooks to explore and learn from. Today specifically, we are going to explore on one of the notebook, which shows how we can optimize stable diffusion using Intel Optim OpenVINO through Hugging Face Optimum, which is um, part of our Hugging Face ecosystem, where you'll be able to directly leverage the OpenVINO format of stable diffusion model, optimize it, and see how quickly it can convert your text prompts to stunning visuals like this. There are three key things that we will see today. As I mentioned, we'll be able to optimize it to either FP32 or FP16 floating point 32 or floating point 16 format, and we'll have the native PyTorch model run on the CPU. We'll have the optimized model run on the same CPU, and we will also see what kind of results we get when we run the optimized model when we run it on a discrete GPU. I'm sure all of you might be aware of the fact that Intel has its chain of discrete GPUs and integrated GPUs. So let's quickly get started. So if you are keen on running this notebook soon after the session or during the session, please feel free to do so. It's very exciting to have your hands dirty with the code. So the notebook number is 236, stable diffusion, and you have like many notebooks to explore and learn from. As you can see, we have two machines on which this notebook is running on. One is the CPU, which is Xeon, and the other one is the discrete GPU, the Flex series. Now, what you're seeing is running the native stable diffusion pipeline on the CPU, and the results are being generated, and you see that it takes about 13 seconds for the native PyTorch model to run and generate the output. As you can see, we are leveraging the Hugging Face pipeline directly for the stable diffusion. And uh, then the next thing that we are going to see is running the same model, the optimized version of stable diffusion. OV stable diffusion stands for OpenVINO stable diffusion pipeline, running on the same CPU. The previous one took about 13 seconds to generate the text prompt, red car in snowy forest, to get it into a stunning visual, which is completely AI generated. And that's the beauty of Gen AI. Now, if we run the same text prompt for the optimized model on the same hardware, you will notice that I'm sure you can see the number here. If you notice what is the number that you see on the screen, please feel free to put it on the chat. Um, uh, and you saw it right. It just took about 5 seconds. So from 13 seconds, after optimizing with OpenVINO, you got the inference in just 5 seconds on the same CPU. Now we are going to see this with same precision. We are going to run the OV stable diffusion pipeline on a discrete GPU. Now you will see the magic that I'm not kidding. The number is real and it's live. So it just took about 1 second to generate the red car on a snowy forest. So it's as simple as that. Um, so what the to put it in simple terms, we have a set of hardware on which we are running the same model and the optimized model, and we see how faster it runs and how faster it generates images. And this is what I've been talking about. You know, generating. Let's see how more text prompts can work. So you see how faster it ran on different hardware, and that's the beauty of optimization. This is what I meant by performance boost. So um, not just that, we are also trying other prompts like the white cyber cat with cool glasses. I'm sure if you can try any text prompt that you love, and you will see you'll have fun generating all these AI images. So let's try to see what's under the hood on the demonstration that we just saw on stable diffusion. First of all, we leveraged the OpenVINO integration with Optimum, which is part of the Hugging Face ecosystem. So we are trying to bring the convenience of Hugging Face with the efficiency of OpenVINO within the ecosystem. And what it means is, again, reducing the number of lines the developers code to run the same model across multiple hardwares. Um, this is one example. The green highlight lines are the actual, if you're familiar with the Hugging Face transformer code, you will be familiar with the stable diffusion pipeline code. The red ones are the the native stable diffusion pipeline code, and the green highlight ones are the number of lines of code you need to change to get the acceleration on the specific Intel hardwares and other hardwares as well. So it's as simple as this, just few replacement of few lines of code, and you'll be able to make it run on a CPU or a GPU, etc. So in stable diffusion pipeline, if we break down the entire key components, we have the unit model, which is computationally very, very intensive. We will further see each of the component in the later part of the session, but unit is one of the computationally heavy part here, and traditional 8-bit post-training quantization for shots of optimization here. So with OpenVINO toolkit and neural network compression framework, we find a solution, where we try to employ quantization aware training among other strategies. We can also do other type of quantization as well, but like token merging and knowledge distillation and so on. This will greatly accelerate the inference, as you saw, and reduce the memory footprint to a great level. And this is really key for an efficient deployment on GPUs or CPUs when it comes to actually deploying any solution that is built out of stable diffusion. So um, it's not just about coding, right? We also get the optimization done based on the combination of hardware we use. So as I mentioned earlier, we saw that generative AI, of course, takes a lot of time and resources, like high inferences. And because of which, if we are building a solution directly with these kind of model, there will be a dip in customer experience if we'll have to wait for a few seconds for the image to generate. So what do you think are the solutions? Like, do you think deploying these heavy models on uh, uh, big sophisticated GPU is a solution? Or if you're an edge developer, how can you tackle the solution, right? Uh, if you ask me, the best option would be to use both. If I can do both and achieve all of this in one go, that'll be the best case scenario. So let's try to see how we can strategically address these pain points. Um, and when it comes to optimizing it, as I mentioned, these are the key components of stable diffusion pipeline. We had the text encoder model with a tokenizer, unit model with a scheduler, and an autoencoder with decoder and encoder models. So these are the key components of stable diffusion that you're seeing here. And the optimizing just one model, like the unit, which I mentioned was computationally very, very heavy, that itself will substantially reap benefits in terms of inference speed. So here, the unit model is computationally the most expensive one to run, and uh, it's just optimizing. It's just a trial that we're doing, right? Trying to optimize one of the component. So if you see, let's see how we can reduce the model size here and how big a difference it makes. As you can see, the FP32 native model's size is close to 4.9 GB. And when I optimize it and reduce the precision to FP16, the memory size is still 4.96 GB, but you would see um, difference in the FP32 optimized version of the same model. But if we are further reducing it to FP16, floating point 16, half precision, then you will see a reduction in model size. And if you can further quantize it, then we humans are greedy, right? We want better performance at every step possible, and we try to optimize it as much as we can. And that's why we have optimization and quantization for. So as a result of reducing the model size, one of the key things that we achieve is faster inference speed, because we are making the model simpler. And as you can see, it's easier to run on a device. If you want to run it on a GPU, you just mention GPU, that's all. And CPU. And if you are running it on multiple hardwares with a combination of CPU and GPU, I'm sure you know the answer if you have attended the previous session. The best option is to use auto AUTO, and that will automatically detect which hardware combination can give you the best performance. So this was one of the key question I asked, like, even before. So today, if you're new to the session, if you think addressing these pain points that you face throughout the AI workflow, if you think you can solve it just with software, then you're mistaken. It's a combination of software and hardware, and we finding a solution for a problem statement, building an AI solution and training it and having it ready. We are just trying to solve 50% of the problem, and the remaining, uh, you know, lies on addressing the critical pain points that are involved in deployment, which is key for building business solutions. So quickly, this is the AI software portfolio for OpenVINO. What you see in the bottom are the hardware lines, the hardwares that we have, like Intel Atom, the CPUs like Core, Xeon, discrete GPUs like Arc and Flex, and other hardwares that, as a developer, that you'll leverage, on top of which you leverage the AI libraries and toolkits, one API models, and build your solutions with these packages, and finally try to build a solution for any of your ecosystem partners and so on, to build a business solution. Excuse me. So if you think OpenVINO is just a concept, then we have all our partners who are already using the recognized companies which are already leveraging OpenVINO to build their AI solutions and keep them running or accelerate them. As I mentioned, if you're keen on trying out all these notebooks that we explored, we have close to about 100 plus demos, um, where we are leveraging various models like the large language models, generative AI models, stable diffusion that we saw today, Whisper, which can convert your audio to text, YOLO V5, YOLO V8, object detection, and many, many more models. You can scan the QR code. Not just that, if you're keen or very particular about just exploring AI training models, then this is the QR code that you can leverage and directly land on many of the notebooks that we have built with the latest and the greatest of the AI models that are coming into market, like language visual saliency with Clip, visual QA with Blip. These are some of the popular models. Infinite zoom, again with one of the stable diffusion model, which can just give if you can just give a text prompt, it'll create stunning visuals like this. Not just that, we also have extensive notebook on large language models, leveraging models like llama 2, quen, chatglm, mpt, and many many more. So I would encourage you to uh, go try out, install OpenVINO, and try these notebooks so that um, uh, what kind of plethora of opportunities that we have that we can leverage through AI to solve some of the key business problems. So with that, uh, all I have to ask is, try it yourself. Just scan the QR code. Um, and if you have any queries in your AI journey, or if you want to know more about OpenVINO, you can connect with me anytime on LinkedIn. This is my QR code. You can click a picture. I'll be happy to help. And thanks for your time today and joining this session. And again, I would request you to quickly take the survey, which can help me enhance the content for the future workshops and webinars. Thank you so much. And if you have any queries, I'm open for the Q&A now. Please feel free to ask all your questions.
Thank you so much, Anisha, for this very interesting session. And thank you for providing also the link for the notebooks for the OpenVINO. I think all our members will be very interested to check them out and try them out. I'm actually amazed of how much you can do with just a few lines of code. And we have a question. Elena is asking, can you show again how we can import OpenVINO in Python, I assume?
Yeah. Can you show again how we import OpenVINO? Yeah. Let me just quickly share the screen again. Yeah. Yes. I guess today what we saw is Optimum Intel, but I'm just checking if I have the runtime code. So because it was about generative AI, let me just show you how we do it with Optimum Intel. As you can see here, yeah. For stable diffusion, specifically for the model that we saw today, we already have the optimized version available on Hugging Face. So how you can leverage OpenVINO through Optimum Intel is, you see these few lines of code, right? From Optimum Intel OpenVINO, import OV stable diffusion pipeline, which is very, very straightforward. And using this line of code and mentioning the hardware on which or the device on which you want to run it, you will be able to deploy the stable diffusion pipeline on the specific hardware. So for example, let me just again show. I hope my screen is visible where I'm just running through the code. Yeah, so this is how we import and compile the Hugging Face pipeline. But when it comes to the other TensorFlow, PyTorch, and other framework models, if you and save model keywords, probably I can share you the QR code where you can go and deep dive and find out how for different AI frameworks you will be able to leverage different methods of importing OpenVINO. Probably this is one of the QR code that you can leverage. It'll take you to openvino.ai documentation page where we have everything in place, clearly documented. So if you want to know specifically a particular AI framework like PyTorch or TensorFlow model that wants to be imported, probably I can help. But in general, this is how you optimize. I hope that
Great.
answers the
Yes,
question.
I think it's
Yeah.
clear, and you can all visit the website of OpenVINO and find out more. I think the notebooks are fantastic, but also there's so many information on the website that you can use. And just a reminder that this session is recorded, so it will be made available on YouTube. And the first part of the introduction to OpenVINO will also be made available on YouTube. I think we'll have it shortly with us, so we're going to share it on our Slack community as soon as it's uploaded, so that you can rewatch it and rewatch this session as well if needed. And of course, Anisha said that she's available if you have any questions for her. She's also in our Slack community, so you can directly communicate with her and also add her on LinkedIn. Maybe Anisha, you can also share your LinkedIn here in the chat, so everyone can connect with you, and if they need any help, you can help. I don't know if there are any other questions. If there are not, Anisha, we would like to thank you for this excellent webinar. I always enjoy when we have hands-on experience and we can actually see something demonstrated and we can actually get some code and play afterwards the event. So thank you again for joining us today and for hosting this. And thank you everyone for taking the time and participating in this event. As said, we're going to have the recordings of both this one and the previous event with Anisha on YouTube, and we'll share it in a Slack. So if there are no more questions, thank you everyone for joining. It was fantastic to have you here today with us. And thank you, Anisha.
Thank you. Thank you very much. Thanks, everyone. It was great meeting you all today.
I'm just going to leave it for a few more minutes if anyone wants to copy the link to Anisha's LinkedIn. Thank you everyone for joining again. Okay. Bye.